All right, hello, Luke. This is, so we have a couple different papers that we're going to fill out. We're going to fill out the bottom two boxes here. We're going to fill out the back side, and then we're going to do section 5.2 notes all the way through that, okay? So, 5.2, you guys should have this top two boxes filled out. We're going to start with centroid, orthocenter, and then we'll go back to the notes, okay? So, this is this paper, and then there's the back side of it. Looks like this, centers of triangles, okay? You might need your note card as a straight edge. Otherwise, you can use just another sheet of paper as a straight edge. That's fine, too. But we're going to talk about centroid and orthocenter, okay? So here is just reviewing back through what we did on Thursday and Friday of last week. We had circumcenter was the perpendicular bisectors, right? So we took each side and we drew like these guys for them. This is a perpendicular bisector. It's splitting this bottom side in half at a 90-degree angle. Those are perpendicular bisectors, okay? Then we go over here to these, and these are bisecting the angles. So it's splitting the angles exactly in half, right? Okay, down here when we talk about centroid, this one's probably my favorite of all four of them, just because he kind of has a fun little thing about him. So I'll show you that here in a second. But he is created from what's called the medians, M-E-D-I-A-N-S. And you guys have heard the word median before when we talk about like data. The median is like the middle number, right? Okay. And so that kind of applies to this triangle here when we're talking about medians, because you're going from the midpoint to the vertex. For each one, you're going midpoint to vertex, midpoint to vertex, midpoint to vertex for all three of them. Where they intersect is what's called the centroid, okay? So we're making all of the medians. We're not doing perpendicular bisectors. We're not doing angle bisectors. We're doing medians this time, okay? So here's how this works. I'm going to go ABC, just like we did before. ABC are my vertices. They're vertices. And I'm going to pick the midpoint of AC, that bottom side. So just kind of eyeball it wherever you think that midpoint is. We'll call him D. And that's the midpoint. I want to go straight to the vertex. So I'm going to connect D to where? B. We're going to connect D to B, and that's going to be my median. That's called a median, okay? And we're going to put the little tick marks at the bottom to note that we did split that guy exactly in half, all right? So let's talk about how he is different, okay? Up in the box right above it, we did a perpendicular bisector. This guy is bisecting at a perpendicular? No, right? It's bisecting, but it's not making a 90-degree angle, right? This is not a 90-degree angle right here. Whoop. Not a 90 right here, okay? Now, is it splitting that angle in half? Is it bisecting that angle up at the top?
No. Well,
not necessarily. Only if this is like a isosceles or equilateral triangle will that happen, right? Okay, so it's not bisecting the angle. It's splitting the bottom side in half, yes, but not at a 90-degree angle, okay? So it's going vertex to midpoint, etc., right? Let's do the other one. So let's call this dot right here E. In between A and B, that is the midpoint. Just eyeball that midpoint, and we're going vertex to midpoint. Okay, he is splitting that right side in half, or left side. Gosh dang it, in this class, it's always I'm directionally challenged. The left side in half, and I put those two check marks there. Is it splitting angle Z exactly in half? No, not necessarily, right? Okay, then we go over to BC, and we put this dot, I don't know, ish right there. We'll call that guy F. They are supposed to. Mine first period was really bad. Okay, that's not too bad. And we'll call that guy Z there in the middle. We'll call him Z in the middle. It doesn't really matter what they're named, but there's that. Oh, I need to put my 3 tick marks here to note that those are the same. So it is bisecting, not at a 90-degree angle, not splitting the angle in half, but those are called medians. It's splitting those guys like such and such a way, right? And this guy is called the centroid. That middle part is called the centroid. Okay? Okay, and when we're finding these, we're kind of like finding like the center of gravity. Like the centroid is kind of the center of gravity, but doing it 3 different ways, right? We're doing the circumcenter, incenter. Those are all finding different points that could be labeled as the center. This one's called the centroid. Now, this one's my favorite of all of them because he has kind of a fun little thing about him, right? Okay, in the circumcenter, we found that like the distances here, we draw this like little pinwheel. What do we call it? Luke's yelling at me right now. A wind turbine, that's what he called it the other day, a wind turbine. Those things all are the same length, right? For an in-center, these 3 of the wind turbines are all the same length. But for the centroid, it's not quite like that, okay? And he doesn't really have any congruent parts per se. I'm going to cross that out, but I'm going to put like important facts. An important thing about him is this. This is kind of fun. I like this. Are you ready? Blink and you miss it. Okay, are you watching? All right, this guy is a median right here. You see the median I just circled? Okay, now this is the little trick to centroid. Ready? This top guy right here, like that line segment, will always be, the longer one will always be double what the shorter one is. Yeah, always in a centroid. So if this guy's 8, what's the bottom one? 4. Let's say that's the case, okay? Let's say that this guy is 1 right here, this thing right here. What's this guy going to be? 2. Let's say that this guy is 6. What's this one? 3. So the longer one will always be double the length of the shorter one. Does that make sense? Where the centroid splits that in half, or not in half, but where it splits it, it will always be double on one side and then single on the other side. Make sense? That's kind of a fun little deal. Okay, so important fact is that the centroid splits each median, and I'm going to draw a little picture. Centroid splits each median. I'm going to go 2 times 1 time. Does that make sense? You see how that works? Okay, so one portion of the centroid, or one portion of the line segment, will always be double what the other one is. So it's kind of fun. It's kind of like a little puzzle. Okay, good? Happy with that? Okay, let's go over to this last one, which is called the orthocenter. The orthocenter. Ready? Okay, the orthocenter is created from altitudes, altitudes. From altitudes. I think we've talked about altitudes before. Have we talked about altitudes before?
I don't know.
I think maybe we have, kinda. Altitudes. You've heard the word altitude before, though, haven't you? Anybody fly in here? You've flied, like flied. So if you've flown in a plane, a lot of times what will happen, most of the time, when you get you ascend and then you get to like the highest point in the plane, and that's when the seatbelt lights come off or whatever, so you can walk around the cabin, or go to the bathroom or do whatever you want to. And the pilot will a lot of times come on and he's like, welcome to blah, 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 Southwest Airlines. We have reached a altitude of 35,000 feet. It is right now 30 degrees out your window. I don't know, whatever. 30 degrees out your window. We will reach our destination in 1 hour and 53 minutes. Welcome to Southwest Airlines. Click. And so he says that, but the altitude that he gives you is like a measurement of how high you are up in the air, right? So let's say that this is your airplane right here for part B. I'm just going to draw a picture of him. Here's your airplane. Okay, let's say your airplane is at point B. Don't make fun of my airplane. Okay, there's my airplane. And AC is going to be the measurement that we're measuring toward. Now, do you know what AC is labeled as? Like, where do they measure to? Like straight down. Sea level, right? Look, AC is going to be sea level. Not necessarily where the ground hits, right? But sea level, because they have to have it like straight across, all the way across the board. So if there's a mountain, it's not going to measure to like the top of the mountain. It's going to measure down to sea level. Okay, so there's how that works. Now, where do we make our measurement to? Like, how do we measure it? Do we measure like this length right here?
No, straight
like
down.
straight down, how so? Perpendicular to the ground. So that's what an altitude does, is an altitude measures straight down, and he has to make a 90-degree angle. I'm going to do my best to do that. There's my 90-degree angle, straight down, right? That is what's called an altitude. An altitude is straight down. You can use your note card to do that. If you put the note card like in the corner there, or like line it up, you will get it completely perpendicular. Okay? Now, if you need to rotate your paper to do the other ones, like rotate them around, like turn them on its side so that like this is now sea level and your airplane's now at sea, you're going to draw him straight down and just pray at the end they all connect. Yeah, me too. Me too. we're just gonna pretend that mine do. I'm just gonna like force them. I'm gonna force them to do that. But anyway, so that's that guy. That's the orthocenter, where they all three connect. Okay, you're making them at a 90-degree angle with all of the sides. Okay.
He's not straight. No, pretty good. At least Libby has confidence in hers.
Yeah, not just got really big.
What?
It made
Your circle just got really big.
Mine actually
Whatever.
did pretty good, actually.
Yeah. So that dot right there. Now, question. Let's go back to this B guy right here. This guy in comparison to sea level, is he splitting that exactly in half? Obviously not, right? Like this is not the same length as this, right? So it's not going to bisect the side. Is it splitting that angle in half? Like up top here, is that splitting that angle in half? No, it's not going to do that either, okay? So, I mean, if I get rid of all my stuff, you can obviously see, like, this angle's way bigger than that one. So, not splitting the angle in half or the side in half, those are altitudes, okay? So, kind of like the median over here, it's not splitting anything in half, except the median does the sides, I guess. But, so this one is not splitting anything in half, it's just going straight down at a 90-degree angle, okay? All right, orthocenter. All of these other ones had a unique quality about them, like these pieces are the same, and these pieces are the same, and this one's double what this one is. The orthocenter? Nothing. It's just an orthocenter. Nothing special about him, okay? So we don't talk about him a whole lot. We mainly just, like this section is mainly just going to be focused on the centroid, like the double and the single, right? But there's nothing really special other than the fact that we can just call it like an orthocenter. There you go. Okay, making all the altitudes where they come together, that's called an orthocenter. Great. Okay, good? Happy with that? Let's go to the back side. Back side of this, we got to fill those guys out. Let's begin with centroid. So, how do we make the centroid again? We're not bisecting the angles. We're not blah, blah, blah. Right. But we draw the three lines are all going to be medians. So, you connect the three lines are created by, I'm going to do just MEDIANS. Let's just write that out. MEDIANS. And the medians are going from the midpoint, which is this guy, to the vertex, which is this guy. We're doing each one of those. Midpoint to vertex. That's what the median does. Midpoint to vertex. Median is middle. Middle is midpoint. Okay? Midpoint to vertex, there's what he is. Okay? That's one of the medians. Do all three of them. That's where your centroid is. Okay? Let's go down to the box. Important facts, a blank is created by a blank connected to the blank of the opposite side. A centroid is created by a blank connected to the blank of the opposite side.
Midpoint?
Okay, so midpoint's going to be the last blank, the midpoint of the opposite side, but what?
Vertex.
Vertex connected to the midpoint. It's going vertex to midpoint, vertex to midpoint. Good? Perfect. Okay. All right, last one is orthocenter. He's created by doing the altitudes. ALTITUDES. We're going to like do all those perpendiculars from our airplanes. Okay. Important facts. And orthocenter is created by a vertex connected to the opposite side so that it is blank to that side. Perpendicular. He has to be perpendicular. That is the key. If it's not perpendicular, you're measuring wrong. If you're not measuring the right altitude. Okay? Perpendicular to the opposite side. All right. Go to your note sheet. We're going to go through these lickety-split, and then I'll give you time to work. 5, 2. I got to scroll down. I'm making Luke dizzy here. Okay. 5, 2, 5, 2, 5, 2, 5, 2, 5, 2. Okay, so 5, 2 is the first thing they talk about is a median. Median is, again, vertex to midpoint. So that's what those guys are, vertex to midpoint. And the centroid, or the median, where the medians connect, that centroid thing, was kind of the fun thing, where I said one side is double what the other side is. Okay, now, I'm going to zoom in on this box real quick, because this is a little bit confusing. They write it like that. They say that CP, okay, CP is this guy. That is 2/3 of CJ, which is the whole thing, right?
Yeah.
That's kind of confusing because I thought I said like double one and the other, right? Okay, so here's the deal. Here's what they're saying here. This is 2 times what this one is. This is 1 times, right? Okay, so if I add all those together, that is 3 times. Does that make sense? So this guy is literally 2/3 of the whole thing, right? They're just writing that a little bit different, okay? One is still double the other one, so if it helps you to think about it that way. Or you can think about it as like the longer section is 2/3 what the other one is, right? Okay. All right, so let's go down here. Let's label this diagram that they have going on here. They're saying that this is a centroid, this point Q. And they're telling us that B, from B to E, this whole length right here is 9. And they want us to find BQ and find QE. BQ, QE. Okay, so I need 2 things that add together to be 9, but one of them is double the other one is. And these ones you might just have to like plug and play. Like what 2 numbers add up to be 9 so that one is double the other? 6 and 3, right? Which one is 6?
BQ.
BQ is going to be 6. The other one is 3, right? Okay, so I'm going to label them over here. BQ is 6. QE is 3. Make sense? Not too bad. I like these. Centroid's the fun one, I feel like. Okay, example 2. They tell me that PT is 2. So this guy right here is a length of 2. They want to know what KP is.
4.
4. It's double that, right? These aren't too bad. Okay, now this lady is trying to balance these triangular like little plates, you know, the plate spinners or whatever. She's balancing these triangular plates, and she wants us to find the centroid or the center of gravity that she would have to put her pole on this triangle in order for it to remain balanced. And Kyle just said, put a magnet on the bottom of it and then you won't have to find it. And I'm like, whatever, Kyle. So anyway, we're going to plot these points right here that they give us in this paragraph. 1, 10, 5, 0, and 9, 5. And we're going to connect those. So 1, 10, 5, 0, 9, 5, and there they are. Okay, and they want us to find the centroid. Okay, so we just have to find the dot in the center that's like the center of gravity in there, right? Okay. So normally we would just like connect all the vertex to midpoint, vertex to midpoint, vertex to midpoint. But I'm just going to draw one of them just to make this a little easier. Let's start with 9, 5, and let's connect him back the other direction because it looks like his median might be that straight horizontal line going across there. Do you see this? I'm guessing that that's what that is. Okay, but we know this is my vertex, right? It's writing. Vertex, that's my vertex. I want to see over here where the midpoint's going to be located, okay? So I want to look for the midpoint of those 2 points. Let's find the midpoint, question mark. Do you remember how to find midpoint of 2 things? Yeah, the midpoint theorem, okay? Midpoint is like finding the average. And if you're averaging 2 coordinates together, to find the average, you add them and divide by 2, right? So we would add the 1 and the 5 together. 1 plus 5 divided by 2 and 10 plus 0 divided by 2. Okay, that's how we find the midpoint. Okay, what's 1 plus 5 divided by 2 going to be? 3, comma, 10 plus 0 divided by 2 is going to be 3, comma 5. So the center there is, or the midpoint there is 3, comma 5. Ha! Boom, it makes a horizontal line straight across. Okay, you see that? That's my one median that I have. All right, now the centroid we know is like the point that splits it into like double and single, right? Like double on one side, single on the other side. How long is that whole thing across there? How long is that median? How many units is that?
6.
6 all the way across here, right? Okay, so what's my split gonna be? One portion of it is going to be 2 and one portion is going to be 4, right? Okay, so watch this real quick. Don't write this down. Watch this real quick. Here are my options. I can either put my centroid here, where this guy is 2 and this guy is 4, or I could put my centroid here, where this guy is 2 and this guy is 4. Which one?
The one on the left.
The first one, the one on the left, right? That's going to be more of the center of gravity, right? Okay. So I want to do that guy instead. So where's the location of your centroid? What? 5, 5. Yep. That's my centroid. Okay. We didn't even have to do all three of the things and connect all three of the medians, right? We could just do 5, 5 and be done with it, right?
Yep.
Good? Okay, let's go to this one here. This is all the altitudes. And they want us to, they only have one question on the orthocenter because he, again, doesn't have any unique qualities about him. But let's go down to example 4, and they want us to plot these guys, and they want us to find the orthocenter. So -2, 4, 4, 4, and 1, -2. And we're going to connect all those guys. Okay, this one's going to be a little more of a guesstimation than the other one is. This one we're just going to like find all of the altitudes and guesstimate. We're not going to like find the exact one because it might come out as an ugly decimal. Which altitude is going to be the easiest one to draw? Do you know? Altitude's going straight.
The bottom point.
The bottom point straight up, right? Like this one's going to be the easiest one to draw. Ooh. Okay, so there's one of my altitudes. The other altitude, I'm going to do my best here. I don't know for sure. I don't know for sure. There-ish. And I don't know for sure. There-ish. Okay, that's where those guys are going to cross. So, if this is my orthocenter, what do you think about the coordinates for that guy?
Like 1, 2.
1, 2, you think? 1, 2? I buy it. 1, 2-ish, something like that. Is where they cross-ish, maybe. I believe it. Okay, so that one's just kind of a guesstimation one. Orthocenter's a little bit harder to do, but there's not as many questions on it. Okay, good. All right, on the homework assignment, I let Chase pick again. And he picks good ones when he picks. He's like, hey, let's on practice side, do 1 through 12. I'm like, okay. Of course, he always like asks to do the ones in favor of not doing the story problem at the bottom. So I was like, okay, whatever. 1 through 12 on that side. And then on skills practice, just do 13, 14, 15, 16. Okay? I gave you like little graph papery things. So there's 2 on one side, 2 on the other side. You might have to like go by 2s or something on it. Sorry, my graphs aren't labeled the very best. But anyway, so there's that. 13, 14, 15, 16 on that side. And then on the other side, just 1 through 12. Good? Happy with that? All right, there you go. Bye, Luke.